Welcome back. Today we are going to do some chemistry. Before we start, we must make sure we have a good enough supply of the basic chemicals. And with the industrial electrolyzer we are good on chlorine, hydrogen and oxygen. However, our nitrogen production is laughable. The fastest way of making it would be to just centrifuge air with the more powerful industrial centrifuge. However, if we first cool down and liquefy air we can get some useful byproducts. But, since we are at it, instead of a centrifuge we can use a distillation tower. That will work a huge amount of air at once and give us a lot of nitrogen and also some really rare and hard to obtain gases. The only issue is that this process need 100 million units of liquid air to start. So, we better get started with 2 vacuum freezers that will reach the required amount every 10 hours. And I hope I did the math wrong. While we wait, we can start working on a set of LCRs that will make the basic compounds, such as acids. Those are going to be managed by AE2 since we will be using those everywhere. And with the new array the old one is just a waste of space, so we can make some room. In the meantime we managed to craft some output hatches big enough to contain the 78 millions of nitrogen units we will be making with our new distillery. And we are at 20% of the liquid air required to do the first iteration of air distilling. So we can build a little bit more of the distillation tower. No hurry, we still have 8 hours. We can use that time to work on the platline. The first step will be to acquire a new piece of land and set some foundations. Where we will start dumping all the machines in multi-block version, starting from this corner. For those of you not up to date, we get something called platinum metallic power as byproduct of various ores. But that dust has to be processed in a complex chain of machinery. The first step is to dissolve this dust inside some aqua regia, so we shall start our line with a huge mixer. And we shall use a multi-block so that we will be able to reach speeds that no amount of single blocks can. And with that we have the platinum solvent. We output that directly into a large chemical reactor where we dissolve the platinum into a liquid concentrate. Using some high-speed pipes we move that into a second LCR, where we react that platinum with other acids to extract a lot of different compounds. To not get lost, we shall bookmark all of those in NEI. The diluted sulfuric acid is looped back into making aqua regia, so we can forget about it. The nitrogen dioxide is recycled into fresh nitric acid, and that's already done. So, the next compound we want to take care of is the reprecipitated platinum dust, which has to be reacted with calcium to get pure platinum. Once of the 2 LCRs we have built so far is often waiting for the other one, so it can instead make that. Next we have to worry about the palladium enriched ammonia, which we can react with the metallic powder we gather from ores. This will give us 2 dusts and the one we care about is the reprecipitated palladium. To process it we need some formic acid. And since this acid has no other usages, we make it in place. We do all the steps in a single LCR, but that might not be the best idea since it won't be able to parallelize when overclocked. Finally, we use that acid to extract palladium. The other byproducts are things that AE2 already knows how to manage. Going back, there are 2 dusts we left behind. Both of those have to be sifted, so we shall have an industrial sieve. Going even further back, there is one more dust we have to process, the residue dust. This has to be heated in a blast furnace with some fluid. The fluid is obtained by liquefying a chemical compound. Making the base dust is easy, but we do not have a multi-block fluid extractor, so we use a single block for the moment, which is really slow. We move that fluid to the EBF so that we can process the residue dust. Then we work the output fluid with an LCR to obtain a bunch of chemicals and the main one is the rhodium sulfate. We react that with zinc. Then we cook the output with a pinch of salt in an EBF. And since we are doing EBFs, we also cook some other related stuff. Thus getting 2 wall-shared EBFs that will do 3 recipes. We mix the rhodium salt so obtained with water, forming a solution, which we move into a chemical reactor with other chemicals to get some rhodium nitrate dust. We sift that stuff with our platline sieve, and that will send back to us some cake. We add some water to it, forming a solution. Then we precipitate it in a large chemical reactor. Finally, we extract some pure rhodium. Going back to the leftovers, we dissolve the sodium ruthenate in chlorine, forming a solution. We heat it up with our new thermic heating device. Once it gets hot and comes out at the top, we bring it down into a distillation tower, where we take out the ruthenium tetraoxide. Then we solidify it. We clean it into hydrochloric acid to get pure ruthenium. And now we can move to the rarest metal residue dust. We start by separating its 2 main components with an EBF. We concentrate the osmium solution output with the help of a distillation tower, using 8000 volts. And even with such high power usage, we get just a tiny drop every now and then. Once we collected enough solution, we can quickly extract pure osmium out of that. And, given the same power, that reactor is 1500 times faster than the distillery. Finally, for the most important output, we add 3 more chemical reactors, thus finally getting the needed iridium dust. And with that, we have fully completed our platline in about 3 chunks in one floor. It is mostly red because we are low on minerals and nitrogen. So it is time to check how our liquid air is doing, and it looks like it will need one more episode to fill up.